Hello, everyone. Welcome back. Today, we're going to talk about interpreting data, but before we do that, I actually want to go over a few definitions with you. Okay, so the first definition is independent variable. Basically, in a relation, the variable whose value you choose and is always on the x-axis. So basically, the independent variable is the x variable, and that's the value we choose. So for example, let's say we want to know the height that a certain person grows over time. Well, we get to choose which time intervals we're looking at, right? And so on the x-axis, it would be the time rather than the height. Then the dependent variable, that's the variable that's on the y-axis, and that's the variable we're measuring or calculating based on the different x values, right? Because someone who is 1 year old, or is just 1 year old, is not going to have as high a height, right? They're going to be shorter than somebody who's 10 years old, right? And so we're measuring based on the independent variable. We're measuring the dependent variable. We're measuring how tall, a 10-year-old is versus a 1 year old versus a 5 year old, and so on. A continuous variable is a variable that can have any value, right? So, for example, there can be lots of different values when it comes to, height or weight or things like that. Whereas a discrete variable means we can only use whole numbers and represent quantities that can't be measured in parts. So, if I'm asking how many apples are on that apple tree, are you really going to tell me there's 5.78436 apples? Well, no, I'd be confused. That wouldn't make a lot of sense to me. So, yeah. Okay. So, with all that out of the way, let's talk about the data. A couple more definitions actually. It says here a relation is a description of how two variables are connected. So, you may have heard of linear relations, right? Relations that are related in a linear fashion, right? Or are connected with the same slope. There's lots of other relations that you'll learn about all throughout high school, including quadratic relations and other polynomial relations and sinusoidal relations and lots of other stuff in the future. But for today, mostly we'll be talking about linear relations in general. And a variable is basically a value of interest with respect to other measured variables, other measured values. So, for example, in an example like we said earlier with time versus height, time and height are the variables, right? We're going to say, well, based on the height, or based on the time rather, what is our height? Now, in this situation, the independent variable would be time, and the dependent variable would be height, right? Because the height depends on the time, right? Whereas time is going to pass regardless, right? The time isn't determined by how tall I am today, right? Whereas the height of somebody is determined by how old they are, how long have they been living, what time is it really? So, yeah. So let's do an example here. Since the year 2000, the number of students at St. Peter's has been recorded. Examine the following data, graph and answer the following questions. So here it asks, actually let's graph it first and then let's answer the following questions. So let's graph this data first of all. Let's also include a title for our graph. It didn't actually tell us to, but let's do that anyway. This looks like it's a graph about the number of students at St. Peter's. So I'm going to say number of St. Peter's students. Oh, that wasn't very good. Let's try that again. Number of St. Peter's students. Awesome, that's a little bit better. Okay. And looks like at year 10, there's 1,400 students. So we've got to end there. We've got to start at maybe about 1,000. So let's do 1,000. Maybe here 1,000, 100, 1,200, 1,000. Ooh, 300, 1,400. Okay. All right. So 1,020 students occurs at one, right, at year one. So 1,020, that would be around there. All right. 1,025 would be around there. And then 1,032 would be a little higher than that, about there. And at four, we have 1,100. So that's a big jump, right? That jumps up to 1,100. Then we have 1,160. Then 1,210, 1,295, 1,330, 1,350, and there we go. All right, so there's our scatter plot. Now it asks, what does the point 5, 1,160 represent? Well, that says that during year 5, which is it's years after 2000. So during 2005, there were 1,160 students at St. Peter's School, which actually I believe that's a high school in Ottawa, if I'm not mistaken. Peter's School, I believe that's a real place. Okay. Now let's also talk about discrete versus continuous variables here. Do we have a discrete variable or a continuous variable? Because remember, continuous variables could be any value, whereas discrete would only be whole numbers. So continuous is like any value, whereas discrete, for purposes of today, is just whole numbers. So in this case, this would be a discrete relation, right? Because in terms of our number of students, we can't have 3.5 students, right? Or we can't have 1,000 and 0.35 of a student, right? We have to have a whole number of students, right? We couldn't just chop up students in half. Whereas when it comes to height or something, that would be continuous because we could have half of a meter. Someone could be half of a meter tall, or 5 feet and 1 inch tall, or 5 feet and a half an inch tall, or any of those kinds of things, right? And so this one is discrete because we can't split students into halves and quarters and things like that. We just can't do that. We'd get sued. Okay. C. Would you use a dashed line or a solid line to join the points? Well, because it's discrete, I would say a dashed line, because not all values are actually are there. I would use a dashed line, right, for that reason as well. So let's do that. Let's use our dashed line. And is there a relationship between the variables? And if so, what is it? I would say yes, there is a positive relationship. And what I mean by that is that the later and later it becomes, the more students there are, right? And so, as time goes on, the student body increases. And we see this across not just St. Peter's School, but a lot of schools. The graduating class of a lot of schools becomes bigger and bigger over time, partly because, and I think the main reason for that for a lot of schools is because more and more people want to go to the school, and there's also more and more people who are needing to go to school, right? Over time, there's more and more people coming into the world, and most of the people coming into the world, or really all the people coming to the world, they start off as babies when they're first born, they're babies, and then they grow up, right? And so we have a higher proportion of people concentrated in younger people who are going to these schools than older people, right? Everyone has to go through middle school and high school and elementary school at some point, right? And so there is a positive relationship, and we keep seeing more and more students because over time there's more people who are being born than who are dying, and everyone when they're born they have to at some point throughout their life go through these schools. And so there's a higher percentage of children, well, not just higher percentage, but there's a higher number, I should say, of children, and every child needs to go to school. It's a law. So yes, there is a positive relationship where as we get further and further along in time, there's more and more students who are becoming a part of the student body and just in the population in general as well. But in the being part of the population means you'll be part of the student body at some point. Good. All right. Let's move along to the next part. This next one says the owner of canine kennels record the ages and masses of all German shepherds that stay overnight. The data for 1 week are recorded below. Examine the following data, graph, and answer the following questions. Okay. So here it gives us the age of the dog in months and the mass of the dog in kilograms. So age of the dog would be this one. And then the mass of the dog in kilograms would be over here. There we go. Okay. So we're going to have mass of the dog in kilograms. Well, let's see. What's the highest point? Looks like it's 22. So if we do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, looks like we can do that. Okay. Beautiful. 10. Oh my gosh. 12, 14. No, that's not going to work. Let's just do by twos then. Yeah, let's do 4, 8, 12, 16, 20, 24, 28, 30. Okay. So let's look at the first dog. The first dog is 12 months old and 14 kilograms. So 12 months and 14 kilograms is right there. Okay. The second dog is 8 months old and is also 8 kilograms. The third dog is 14 months old and 15 kilograms. The fourth dog is 4 months old and 5 kilograms. Like that. The next dog is 10 months old and 13 kilograms. The next dog is 11 months old and 10 kilograms. The next dog is 16 months old and 20 kilograms. Oh. And the next dog is 15 months old and 16 kilograms. The next dog is 5 months old and 7 kilograms. And the next dog is 18 months old and 22 kilograms. What does the point 10, 13 represent? Well, this represents that there is a dog, or there is a dog that is 10 months old and weighs 13 kilograms. Okay. Is the relation discrete or continuous? Okay, well that's a hard one actually. I would argue that it's continuous because technically we could have half a kilogram or a quarter kilogram, right? We could have a dog that's 8 1/4 kilogram. That is possible, so I would argue that this is continuous. However, they actually only gave us whole numbers for the kilograms in this scenario but I would still say continuous because it is possible to have a dog that weighs, that weighs 5.5 kilograms. It's not that that isn't possible or something. It certainly is, right? Okay. Would you use a dashed line or solid line to join the points? Well, that's an interesting question. I would definitely say if we're going to use a line to draw the points, perhaps a dashed one, because this is, although it is continuous. However, mm, here's the trouble. I would say no line. I would say we would use no line to draw these points to connect them together because each point in this case, it represents a different dog, right? It represents a different dog. So I'm going to say no line because each of them is just representing a dog. Whereas with our last example, we had the number of students, right? It was the number of students, and so that number would increase or decrease, but a lot of it would just be the same students across the year. This is where every point represents a dog. So we could take away points, we could add other points, depending what happens next week. So this isn't really a plot where we would you know put some line in there. It wouldn't really make the most sense. Is there a relationship between variables? If so, what? I would still say there's a positive relationship, maybe not as strong as the other positive relationship, but overall we do see the trend that in general, as the age of the dog increases, as the dog gets more months old, their mass increases as well, right? Their weight increases because they're getting older, and these are very young dogs, right? Dogs who are under 1.5 years of age, right? 18 months and under dogs, and so they're still growing. Now there are some exceptions to that, right? There's a dog over here, for example, where it's 10 months old and it weighs 13. And then there's another dog that's 11 months old that only weighs 9, right? So, and there's a couple other exceptions like that as well. um, However, overall, in general, we know that the weight of dogs goes up as they get older, right? As they continue to become more months old, their kilograms increase on average, especially too. This is all the same type of dog. This is specifically German Shepherds, right? So this would be a lot more varied if it was different types of dogs, because some types of dogs, even as adults, they're still very small, whereas other dogs grow very big once they become adults, and other dogs, unfortunately, you know, not much, right? So it just depends. But this is all the same type of dog. So overall, I would still say a positive relationship, even though there are some exceptions. Overall, the trend is positive, right? Just like with heights of people, right? I'm sure there's some 10-year-olds that are taller than some 12-year-olds, but overall, the average 12-year-old is going to be taller than the average 10-year-old. So think of it kind of like that, where it's on average what's going to happen here. All right, well, that is it for interpreting data. Good work today, and we'll see you next day. Bye, everyone.